Okay, hello. So this is a tutorial video for Serum. In this video I'm going to be showing you the basics of Serum, a small bit about the science of certain components that we have here, and not gonna lie, it would be mostly talking, so don't expect to see much. I'm just gonna do a few small things, pointing out things with a mouse and so forth, and a few things showing you what you can do on the synth. Right. So first of all, what is a synth? A synthesizer is an electronic musical instrument that generates electric signals that are converted to sound through instrument amplifiers and loudspeakers or headphones. So, here are the components, and the first component we're going to start off with is an oscillator. There's other oscillators. You can see we've got two oscillators. We've got one sub and a noise oscillator, which plays a noise sample at the same time as the synth. So if you might be able to hear one. There you go, that's the sub and the noise. And an air can played at the same time. Alright, so what is an oscillator? Well, the oscillator I'm going to talk about, which is the main two oscillators. An oscillator provides a source of repetitive AC signal across its output terminals without needing any input except a DC supply. The signal generated by the oscillator is usually of constant amplitude, meaning the amplitude doesn't change over time. As you can see, the oscillators in Serum can produce all the basic waveforms, the sine, the sawtooth, triangle, and square, and are shown in visual form by a wavetable. This is our default one here. So, what is a wavetable? A wavetable is just the device that contains the data of the waveform. In Serum, we see the data visually and can edit the synth using wavetable synthesis. You can edit preset wavetables, and create your own with the editor. It shows the change in the waveform by cutting it up into samples. So if you were to import one, you would see all the different samples laid across here. Let's get some of the old ones. Where are they? Basic shapes. So the basic shapes one, these are all the basic shapes, but put it into one wavetable together, as you can see. It's not that likely you use modulation on this for a synth unless you wanted to modulate between a sine wave and a sawtooth or something, or a triangle. I don't know. But to carry on, these data samples of the waveform are what creates a wavetable. As you can see here, we've got a wavetable with things that won't really sound well together if you modulate them. There you go. So what an LFO would do, you just put that on there. Not really what you want, is it? No. Alright. But anyway. How wavetable synthesis works. Wavetable synthesis is a sound synthesis technique that employs arbitrary periodic waveforms in the production of musical tones or notes. It is currently used in software-based synthesizers, for example, Serum, what we are using. Well, you might be asking, what is wavetable synthesis then? So, wavetable synthesis, to understand wavetable synthesis first, we need first, a signal in the context we are using is an electrical signal. Our signal is being generated by an oscillator in the synth. It is then being shown to us through the wavetable, showing us the process of sound synthesis. Sound synthesis is where periodic electric signals are converted into sound by amplifying them and driving a loudspeaker or headphones with them. So, in wavetable synthesis, you edit the voltage waveforms using sound synthesis to create tone-like sounds. Arbitrary periodic waveforms, however, are a random change repeating the exact same shape again and again to create a waveform that doesn't change, so both its shape and harmonic content stay the same for the waveform's duration. This is used more to create sounds that are similar to instruments in real life because the harmonic content doesn't change over time. So what I'm saying here is, for example, why this wavetable doesn't go together is because they're generally the individual sounds. So you'll hear a sine wave being played over and over again. But if you do what we're going to do now, this is you change it. This is used more to create sounds for the similar instruments, like I said. So, what I will be doing as a producer, I'm sure what you will want to do is edit the waveforms over time by adding distortion and modulation. This can be done by adding filters and LFOs, maybe even using macros to the program in your digital audio workstation and automating them in your digital audio workstation. But for example, this isn't the usual wavetables you get. You can find some, let's find like a growl or something. No, see look, this is one here. See how it progresses. All these sharp kind of lines are all the distortion, where it's distorted. Obviously, as you can see, like a sine wave here. So more of a distorted sine wave. If you want to change. Right. You can also change sounds by using filters. An audio filter is a frequency-dependent amplifier circuit working in the audio frequency range of 0 Hz to be on the height of human hearing, which is 20 kHz. The lowest a human can hear is 20 Hz, which means the filter can also affect the LFO without a human hearing it. Audio filters can amplify, e.g. boost, pass, or attenuate, which is cut some frequency ranges. For example, the cutoff would be the high frequencies. The cutoff would cut the high frequencies from about 22,050 Hz all the way down to 8 Hz. So, for example, if you put the cutoff from all the way down to 19 and below, you wouldn't be able to hear that much at all, because depending on if you go lower, because only low, for example, if we put a sub on it, put it through the cutoff on. Okay, why is it not making a sound? Oh, of course. You can slightly hear it. Obviously, if you go lower. Anyway, the reason for this is because of the filter you choose, obviously, but it basically means it starts cutting frequencies at 8 Hertz. The filter you use will control what frequencies you hear, so a low pass will let the low frequencies pass through the filter if you put the cutoff all the way down with a low pass filter, for example. So we've got the low pass and the cutoff all the way down. You won't be able to hear like hardly anything at all. Oh, come on. Sorry. That's why. I was wondering why I was making noise. It's the sub bass. You won't be able to hear that much through the oscillator. You might have heard something actually because the LFO on it. Sorry about that. So a low pass will let the low frequencies pass through the filter, and a high pass will let high frequencies pass through, for example. The reason why you can't hear most of the sounds, you might be able to hear a bit, is because the cutoff is at 8 Hertz, which is under the range of human hearing, but it was still let through. The filter was still let through a small part, maybe about 20 to like 24, 30 Hertz through the filter. You don't know. Depends what filters you have. There's no filter, I'm sure, that cuts all the way down, because that'd be ridiculous. You don't need to use that in a synth. A bandpass filter is basically a mix of a low pass and a high pass filter combined to isolate a group of frequencies to pass through while everything else gets cut out. So if we just put one on now. You can boost or cut. See? You can do a lot of things. There's a lot of different band passes. This is cutting and just leaving mainly the mids of this. Alright? Okay then. Oops. Okay, so that leads us on to the LFO. If you want to do some modulation. So the LFO basically means a low frequency oscillation, or what we have here, a low frequency oscillator. Low frequency oscillation is an electronic signal which is usually below 20 Hz and creates a rhythmic pulse or sweep. The LFO is used to modulate the synth and is used to create effects that are used a lot by producers. If that's something you want to get into, for example, an example is using it to create a vibrato, a pulsing change of pitch. You can give it different characteristics for in the synth, for example, using the rate. We'll just do that now. Drag it onto the pitch. Simple vibrato if you turn it. There you go. many things you can do to change the characteristics. You can even alter the rate through the BPM of your track. That's a good tip. Right. ADSR envelopes. ADSR envelopes function is to modulate aspects of the synth sound. So the main aspect of the envelope is to modulate loudness over time, something you change by using attack. How quickly over time, sorry. Something you change by using attack, how quickly the sound reaches full volume after the sound is activated. Decay, how quickly the sound drops to the sustain level after the initial peak. Sustain, how constant the volume is after the release. And release, how quickly the sound fades after the note stops or the key is released. Right, that is ADSR. Attack, decay, sustain, release. This can be used to create different sounds. For example, you can make maybe a plucky sound now by putting an envelope on the cutoff on the filter and modulating it. So don't use envelope 1 because that controls the master. If you want to do modulation, use envelope 2 or 3. Bang on the cutoff. If we turn the cutoff all the way down, so the cutoff will start with pretty much nothing coming through the filter, or it will end because we're going to change the envelope to make it like that. So what we want to make a plucky sort of sound is put the attack down, because we want to control how long the note lasts. Obviously we don't want that much decay at all because we want a plucky sound. Oh, what have we got? LFO on. Yes we do, we have an LFO assigned. Remove. Right, there we go, clean signal. So now what we want to do is put down the sustain. Obviously, as you can tell, that fades off, but because we've got, we do this on certain. That's why we want a filter that can cut off more from the start. So as you can see, what the filter's doing here is starts off obviously, and then when I press the note and I'm holding it down, I'm holding this note down. That's the difference. I'm not just pressing the note to make it sound plucky. You can do that, but there's not really. I'm just showing you how you can do it in the synth to control basically how long you want the note to last. Maybe if you want it to fade off with a bit more release. I don't know. Depends on what you're going for. But this is a main way to sort of get a plucky sound. You may not necessarily get if you just use a MIDI note and just cut it off. It starts punchy, it starts high, full sustain, and then it cuts down, and then releases off instantly. So it gives a plucky sound. Even when I'm holding it down, it's still cutting the initial sound out because the sustain is put on a percentage that is lower than the actual sound coming through the filter, so the frequency just is lowered. Sorry, it's hard to explain. Anyway, that's basically it for envelopes. Make a little plucky sound. Apologise for the amount of pauses I'm doing, because generally I'm having to do this free, just live, as I'm doing it, as I'm explaining it, because my editing software is not working, and by the time I get it fixed, I will not have enough time to hand this in. But yeah, I've done the planning for everything, done the plan for this video, but I haven't handed it in. I just haven't recorded it. Anyway, last tip for Serum is the sub bass that you can use. It has 6 waveforms to choose from. You can change octaves, go down a couple of octaves, take that away. Whoops. What is it? There we go. You can hear that. You can even put an LFO on the sub bass. You can edit the sub bass. Put an LFO on the pan as well, the panning. But the main feature I want to talk about is this direct out button. Now, if I get a, let's just get a preset up of, oops, let's get a preset up. There we go, it's got a lot of effects on it. We mute the oscillator. It's just a sub. You can still hear it's being modulated by the LFO on the level, and it's still getting distorted. So if we put the direct out, it's just getting modulated through the LFO. And if we take the LFO off, it should just be plain sub bass, but because the level is not down, I'm not hearing. There you go. That's bass off. And that should be doing it for now. Obviously, I'm sorry for doing this sort of live. I haven't had enough time to really do anything other than do it live, because the rendering process is going to take ages. Anyway, thank you. I hope you've learned something, and goodbye.